Okay, so we have now a situation where we want to collaborate over the boundaries of two different municipalities, to a commune in Sweden, say, for example. But this applies to all of the globe, really, where you have local projections. So you're in one coordinate system and you want your coordinates in another coordinate system. So how do you go about it? You can't just say to the computer, this is a different coordinate system. You have to do a transformation of the coordinates. The simplest one we can do is a reprojection. If we're using the SBG051 model of the Earth, and we have our coordinates in, say, 18, we've put the piece of paper of the 18th meridian touched there, and that's our those are the coordinates we have. But now we want to actually have them in 15. So we've moved over a bit, put the piece of paper to touch the globe of the 15th meridian there. How do we go about it? So this is our original piece of paper. We have our information there and our coordinate system that we've gone out and measured. So what do we do? And it's equivalent to that point on the globe. So what do? We want to go from this to this. What we don't do is just go straight up like that. That's a big no-no. You can't do that. What you have to do is go back down to the model of the Earth and then back up again to the new piece of paper. You have to do this two-step thing. Back down to the model of the Earth and then reproject out to the piece of paper. And as you can see, the error over here has become greater. It's moved farther away. We've got a scale difference thing. It's moved farther along the piece of paper because we're farther away from this central meridian, which is what we don't want to be. The errors get greater and greater the farther along we get. But we've decided we have to do this in order to collaborate over the boundaries. But we've incurred this problem. The data on the surface of the Earth, or on the surface of our spherical model, is fine. But when we try and measure things on the piece of paper, it looks a bit weird. But what happens if you're not you're moving from SBG051 or from RT90 to SBG051 or the other way around, or just two different models, whichever they are. And in this case, we're saying we're going to go from, you found some old data somewhere, somebody's got a map or an old aerial photograph, and you want to use it in your new work. But it's been recorded in RT90 2.5 new degrees west. And you want it in SBG099 TM, say. So what we have to do then, we have a similar problem plus a little bit more to deal with. So we have our two different models of the Earth. We have this black ring here, which is one model, and we have the orange, which is another model of the Earth. Two different models have been used at different times. And we can't do this that we saw previously. We can't just go straight up. That's not a valid way of doing things. What we have to do instead is we go down to the surface of the Earth on our model. We're on the RT90 model now. We go down to that model. Then we need to shift from that model to the new model or the other model of the Earth, whichever one we're using. Once we've made that shift, then we can reproject out to our piece of paper from that center outwards. In this case, it's from the center. That's the projection we're using. So we've gone from the piece of paper down to the Earth, switched our model of the Earth, and then gone back up again to a new piece of paper. That's reprojecting. And that's something that you need to be aware of when you go from, if you find your old data in a cupboard somewhere or on a computer that is in this old coordinate system. These steps need to be done. Now, of course, the computer is really going to do all the work for you. You just have to tell it to do this, but this is what has to be done. It's not a straightforward process. And the reason for going through all this is to just make that point. You have to actually transform the data. You cannot just tell the computer these coordinates are now something else. It actually has to be mechanically performed by the computer or by you if you really feel like it. It's actually not mathematically that difficult for one coordinate. Once you start doing it for lots, then it's time consuming. But this, just to quickly go through this this datum change, when we spoke previously about this, the Cartesian coordinate system, geocentric Cartesian, where we had the datum shift, and that's just come in recently there when we went from one coordinate system in RT90 to SBG051, we needed to make that jump from one model of the Earth to another, and this requires a few parameters to make this change. We need to do a translation. Translation is just moving in a line from one place to another. So we have our two different models of the Earth. We've got a point on the surface of the Earth in our geocentric Cartesian coordinate system with the x and the y and the z marked out here in reference to the central point there. And then we need to move over to our new model of the Earth in this orange one. And to do that, we need to find out what that translation is. What is that distance from there to there? And this requires then, in our old system, in the one we already know that we exist in, how far away is this new center point? How far away is the center of the Earth using this x, y, and z coordinate there? So we define that translation. Start from here, where you know you are, move that much over, and that's the new center of the Earth for you. So we get the old system plus this movement, and that gives us the start point for the new system. But there can also be a rotation. Our model doesn't have to sit nicely in with the old one. It can be rotated around it in some way. It can be rotated around the x and the y and the z. So we need to add those in order to get that rotation. So the old coordinate system plus a rotation gives us the new one, as well as the translation. And then there might also be that our new model of the Earth almost certainly isn't the same size, that there's some sort of rescaling needs to be done of the axes. So we need to take the old, multiply it by our scale factors, and that gives us our new coordinates as well, or part of the new coordinates. So all of these 9 parameters are needed. So we had the translation in x, y, and z, we had the rotation in x, y, and z, and the rescaling in x, y, and z, in order to move from one model of the Earth to another. We're still standing on the same point of the Earth. The model of the Earth has sort of moved underneath us, as it were, and now we're on this new model of the Earth.